This is Thoughts Video 5.5, I'm going to call it. It's a lot to do with the previous video, and I just thought I had a couple extra thoughts that I wanted to express on the manufacturing side. So first off, in the 3D vertical farm, I was talking about how you have this robotic arm that lives on this crossbar that can go laterally, and the arm can go the perpendicular direction, so you can reach any 2D point on that plane. But the more I think about this, you don't just use that farm for farming. Because it's a robotic arm, it can actually also go in the up direction. And above this crossbar, of course, would be the light, like the lights for growing, the growing lights, and like mechanical stuff for distributing water and CO2 and any other consumables. There is a possibility that maybe the water will go subsurface, but like maybe you water from the bottom up. But anyways, you just have maybe not though, because then it's more difficult to maintain, like for maintenance. But with regards to maintenance, you actually can use this robotic arm not just for farming, but also for maintenance. So if you ever like have growing lights that go out, or you have any mechanical issues, this robotic arm can also be used for that as well. Again, because you don't want any biological productivity. You don't want any humans in this thing. This is just fully automated digital brain, digital muscles. So yeah, it can, and yeah, so it can depending on the end effector on the end of the robotic arm, it can do anything in the farm. And of course, the end effector is just like whatever is on the end of the robotic arm. So for maintenance and stuff, it would be some sort of hand-esque looking thing that, or you can have custom end effectors for whatever you're doing. And then for the lights itself, you could just redesign how you think about this, and maybe have it just so that you're able just to kind of like, it's like a friction fit, interference fit plug situation. So the robotic arm can just like pull it out and then replace it and shove the new one back in. Anyways, just like you would be able to use this for maintenance as well. And just like quickly on this, you probably would have a bunch of sensors in this whole thing as well. But again, you want to minimize the amount of sensors. So on the arm, for instance, you'd have a camera, and then you would build a digital, like a neural net here, like a farming neural net to solve this problem. But it wouldn't just be for, of course, like, because it's traveling every place in this plane and it has infinite memory essentially, it knows, it can optimize. Like, you can set what you want. Like, it can do a bunch of iterations continuously to figure out the exact right conditions for everything and the right time to harvest and all this stuff. And again, you just set where you want to go, and it'll figure itself out with like what height or what hue or how much time or whatever, until the crop is ready to harvest. And it can do iterations on these things, so it can change like CO2 concentrations, or it can change the moisture content, or the cycles of the lighting, or all these kinds of things, so that again, you optimize. You want it as efficient as possible, and you want it to happen as efficient and as sustainably as possible. So yeah, and then that's end effectors for maintenance. You have end effectors, of course, like you'd have like the seeding thing, you'd have like the plowing thing, you'd have it'd be like combine-esque thing, and you could just iterate on these end effectors, so that maybe it's doing not just the like, if it's like a combine-esque end effector, then you'd also maybe want to separate the wheat from the chaff right there, and then you can iterate on this as much as possible so that everything can get done. Or maybe even like grind the grains into flour like right away before it even leaves. And then of course, like, you'd have also in this, you could have areas that are like you're literally making bread, or just like all automated. And this neural net could then just iterate, and not only would it recognize when like to crop stuff, but it also has this camera here that sees everything. So it's like, okay, it sees that a light is out, or that mechanical breakage or something like this, then it can go on and fix this automatically. It can change its own end effector. It knows exactly what to do. It's done this all a million times before. And so again, you minimize your biological productivity. Just do this all with the digital, like the technological muscles and the technological brain. But more than that is that you can actually use because that automates growing and all that stuff, and harvesting and processing, but then you could also use it and maintenance. But then you could also use it for building this 3D cube itself. So if you think about, you're on ground zero, and you just have like this digital arm, or this technological robot arm. It could actually, if you could have automated deliveries here, it could see the deliveries are there and maybe they're marked somehow, or it can just see that it's like what material has been brought there. And if it's delivered at the right place, it can just like reach over, start grabbing these beams, steel beams or whatever it is, and just build itself. It can place it in the right place. It can torque bolts. It can do all these things itself. So you literally get to this place where you have automated trucks delivering materials to this automated self-constructing factory, like food factory. And so like literally this whole thing, it builds itself, and then it grows itself and processes itself and ships food itself. Like this whole thing is just fully automated, powered by the sun, and like and told what to do by its digital brain. And this is like neural nets, of course, doing these things, like far more complex things, like in driving and stuff like that. And this, in relative terms, is far, far easier than that. And so, and again, when you want to minimize manufacturing complexity, what you would do is, one of the things you could do is you want to standardize as many of the beams as possible. So to have like standardized lengths of stuff, you maybe would want to have like the width equal to the length. Or if you had a more rectangular space, you would just go in multiples of, like the length would be in multiples of the width, just so that you'd have standardized things. So the length is 2 width, or the length is 3 width. And so that you just have this like 1 width length of beam or whatever, and that can be used repeatedly through this whole thing, just to again minimize like the complexity of building this thing, and then on the supply chain as well for the beams itself. And then just deliver these things, and it just self-builds itself. It has access. It can pick up other robotic arms, but as it's building itself to help. So you get in this place where you just want to create this like this cybernetic food farm thing, and it just does everything itself. And this is again all in the name of making this whole process of food and all your pillars of civilization zero marginal cost and fully sustainable and fully resilient. And while this maybe seems silly in like developed countries, quote unquote developed countries, self-proclaimed developed countries, but in places around the world that just have are just starving and are spending like obscene amount of money to bring to ship food into their country or their region, this is life changing, country changing, continent changing potentially. If you iterate on all of your pillars of civilization to get them to fully sustainable, fully resilient, zero marginal cost. So that would be one more mental iteration on the building out of the farm. The quick other thing was shelter construction and manufacturing as well. I was mentioning that you'd be growing. Hopefully we could iterate and build organic, or like use organic material as the main feedstock to build these like wall panel things. And of course it's all in one panel. So it's the exterior shell, that's weather resistant. It's like the insulation, it's interior finish or whatever. And it doesn't, just like think of it like this is gonna be totally different than what we're used to today. But again, in our quote unquote developed world, this may seem funny, but like this again is game changing, like life changing for if we can provide a safe, healthy, warm, connected home for not a small fraction of the earth, but 8 billion people. This is the goal. That's why you need this as zero marginal cost, fully sustainable and resilient. Because a vast majority of the humans on planet Earth, I know, it's just like it's not often thought about in our everyday life, but they don't have these things at all. And even now, it's because this whole train is going backwards. Even in these developed countries, it's like being able to afford a house or energy or movement or whatever, all these things is getting more difficult. So this is again why those have to be your optimizations. And we can do this. We have, again, when you utilize the digital brain and the digital muscle, and optimize your efficiency of manufacturing and design and deleting as many things as you possibly can, and just optimizing this whole thing. This gets you to this will get you there with a lot of work, I might add. So anyways, for the shelter, if you're growing this organic material, using this as your primary feedstock, initially I was thinking that those panels could then be shipped by automated, like by autonomous truck or whatever, to autonomous electric truck, which is also powered by the sun, to the build site. But a lot of these places around the world, maybe they don't want to build out full road networks, which nor should they. Why do you build your whole environment around these cars and trucks and all is silly. So you won't have to build all your roads first, and then it's just silly. So like what you could do is use heavy lift VTOL electric drones, automated electric drones. And this is like, I'm talking like heavy lift here, because then they could just like, you could have either your full shelter or maybe at the max, like 2 pieces or 3 pieces or something. And then just like plug it in to the foundation. And the foundation has your 3 utilities from the underground utility network and electricity, water, and fiber for connectivity. And so, yeah, it just drops onto this foundation from the factory. And then you have less seams, because seams is always the pain in house building, because you get these like infiltration and moisture and all this nonsense. So if you can avoid that and build it more holistic build panels, like larger panels, so you're not worried about fitting on a truck or getting transport. And that just deletes the silly constraint of having to navigate through roads and all that kind of stuff. And it just makes it less complicated on the logistics part of it. Just go up and over and down. And yes, I'm sure it could be annoying for the time that you're doing this, but this will be short durations. And so maybe a community would have this quite a bit for some time, but once they're built out, then you wouldn't have this heavy lift thing. But again, this is an optimization along your path towards fully sustainable, resilient, and zero marginal cost on the home thing as well. Yeah. So I think that was it on those 2 things. I just wanted to just discuss a little bit more about some mental iterations on what things that we should try on the manufacturing side. There is so much to be done there. And yeah, so like just think about this like in terms of the back to the farm thing. If you just have it, all that has to be done is for both the farm and the house, just all that has to be done is getting the foundation set. And arguably you could automate that quite a bit as well. But this is a little bit more difficult because it's uncontrolled. Everything that's done within a farm or a set conditions or whatever can be done in a more controlled conditions, but because you don't know, everywhere around the world has different substrates, like different subgrade materials and different constraints that they're working against. So you might need some biological productivity involved there in the beginning anyways. I suspect in the long run, you'd probably be able to automate most of that as well. And then you want to maybe in the beginning, of course, it'd just be like concrete or whatever. But I think that you iterate on the concrete situation as well. And to get to be, again, more sustainable, more resilient, and zero marginal costs on that. And then just have your 3 prongs sticking out of the ground for fiber, energy, and water. And yeah. And right where those are coming up out of the foundation, then that's where your cornerstone panel is set. And then again, within that cornerstone panel, you have the embedded heat pumps for conditioning the air from outside. So that can just come straight through the wall and get conditioned through a air source heat pump situation, and then goes through the utility channel through the perimeter of the house. So you have very clean, filtered, conditioned air coming in. And then the water can get conditioned, either heated or cooled as well. Well, typically mostly only heated. And then, your fiber would just go into some embedded Wi-Fi router within the wall as well. And these, of course, could be like access through a panel or something like that within the wall. But you want it to just like plug and play. This is a good way. Plug and play your house. Plug and play your house. Should probably cap it there.